Hi, my name is Dave Belanger,
And I'm Dan Orth.
and we're going to be doing a problem involving the Doppler effect, which is in Chapter 12. And yeah, so the original question states that a bat flies towards a wall at a speed of 5.0 meters per second. As it flies, the bat emits an ultrasonic sound wave with a frequency of 30.0 kilohertz. What frequency does the bat hear in the reflected wave? That's the question we're being asked, and now we're going to show you how to do it. Okay, so before we start this problem, we just wanted to introduce to you 4 different scenarios that are involved in the Doppler effect. We can break these down into 2 categories, where the first 2 are when the source is moving either toward or away from a stationary observer, or we've got the bottom 2 here, which have the observer moving either toward or away from a stationary source. So the first 2, for the source moving toward a stationary observer, we would use the formula f prime is equal to the given frequency over, and then in parentheses, 1 minus the fraction velocity of the source over velocity sound. That gives us, that's the formula we use for when the source is moving towards the stationary observer. The second one for source moving would be when the source is moving away from a stationary observer. In this instance, we would use the formula f prime is equal to the given frequency over 1 plus the fraction v source over v sound. When it comes into the scenario where the observer is moving towards a stationary source, we would use the formula f prime is equal to 1 plus the fraction v observer over v sound, close parentheses. So once you get that, you multiply it by the given frequency. So that's what you'd use for that scenario. And then for the last scenario, it would be the observer moving away from a stationary source, and that formula would be f prime is equal to 1 minus the fraction v observer over v sound. Close that in parentheses and multiply everything by the original given frequency, and that's how you find that. So now that we know the 4 scenarios and the 4 different formulas, let's put that into effect. Okay, so from the 4 formulae that we showed you in the previous slide, here's the 2 that are going to be relevant for our example. In this one, just to reiterate from the last slide, this formula is for when the bat is sending its signal out against the wall, and then the second formula is for when the wall is reflecting that signal back to the bat. So I just wanted to emphasize which formula will be used for which part, and just keep note that the bat is always flying towards the wall. The bat is never flying away from the wall. However, the sound wave does go towards the wall and then eventually reflects back to the bat. So just to clarify that, I'm going to move on to the next slide and show you how this example actually plays out. Alright, so to solve part 1 of this problem, we're going to be using this formula right here, which is f prime is equal to frequency over, in parentheses, 1 minus v source over v sound. So this is what we know so far. We're given that the speed of sound is 343 meters per second. We know that the bat is moving at 5.0 meters per second. And we know that the frequency it's emitting is 30.0 kilohertz, or 30,000 hertz, in parentheses right there. So now we're going to start plugging numbers into the equation. So to rewrite this again, it would be f prime is equal to, and then we plug in the original frequency, which is 30,000 hertz. So we'll plug 30,000 hertz up here in the numerator. We're going to disregard units for the time being until we get to a final answer. It just makes things a lot easier. We're not going to use sig figs either until the very end of the problem. So 30,000 is the 30,000 hertz, and then in the denominator, we're going to have a parenthesis, 1 minus, and then we substitute v sound and v source where it's appropriate. So v source is 5.0 meters per second, and that over 343 meters per second, which is the speed of sound. And when we end up solving this, let's see, our f prime is going to be 30,000 over that. Our answer is going to end up being 30,000 hertz over 1 minus, and I'm just going to simplify it for you. 5.0 divided by 343 gives you 0.01548. I'll just simplify that for you. Now, to go another step, we're going to want to take 1 and minus this 0.01548. When we do that, our answer is going to start looking a little bit more simple, you know, not so many numbers everywhere. So it's going to be 30,000 divided by 0.98542. And then once we divide this, our f prime becomes a rather large number. We're going to get something around 30,443.79. Now we're not going to use sig figs or anything like that like I mentioned earlier, so we're just going to leave this for now. So 30,443.79 is our f prime for step 1. Now what we're going to do is we're going to take this 30,443.79 and we're going to plug it into the next formula, which we will show you in the next slide. This will all make sense. Okay, so moving on to step 2 of this problem. Now that we've already found f prime, the answer to step 1, which was 30,443.79 hertz, we want to find the frequency of the wave that comes off the wall back to the bat. So to do this, we're going to use this formula right here, which is f double prime is equal to parentheses 1 plus the fraction v source over v sound, close parentheses, and then multiply all that junk by f prime from the first step, which is right here. So to start doing this, let's just take this formula, rewrite it up here, and start plugging in some values. Now, to do this, we're going to write f double prime is equal to 1 plus 5.0 meters per second, because that's v source, we're going to plug that number in, over v sound, the speed of sound, which is, as you know, 343 meters per second. We're going to close that parenthesis, and then we're going to multiply everything that's in this parenthesis by 30,443.79 hertz. Okay? Now, in the first step of this problem, we had this exact same thing, 5.0 over 343. Now, this ended up giving us a value of 0.01548. So, I'm going to simplify this part and just write 1 plus 0.01548. Okay? And then just copy down the 30,000 blah 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 from earlier. Okay? At this point in time, all we want to do is add the 1 and the 0.01548 together. That's simply going to give us 1.01548. And we're going to multiply that by the 30,443.79. We simplify that on the next line. It's going to end up looking like 30,915.05987. Okay, so this is what we got so far. We're at the end of the problem now, so we're gonna want to implement significant figures and shorten this up, make it look a little bit neater. So to do that, first we're going to want to go back to the beginning of the problem, look at our given values. We got 5.0 meters per second, and we've got 343 meters per second. When you're using significant figures, you want to choose the smaller amount. The 5.0 here is 2 sig figs, so we're going to pick that one. So, if you look back at our humongous number here, I guess, what we're going to want to do is shorten this using 2 numbers and some power of 10. Hopefully you all know what sig figs are by now and how to use them. So I'm going to shorten this. I'm going to move the decimal 4 points to the left, change this 0 to a 1 because the 9 is higher than 5, and it ends up looking like 3.1 times 10 to the 4th hertz. This is definitely the correct answer. You're welcome to test it